There is a moment in every great scientific revolution when the map stops matching the territory. Not because the territory changed. The territory never changes. It is the map that was always wrong. And sometimes the first sign that your map is wrong is not a dramatic explosion, not a collision of galaxies visible from billions of light years away. Sometimes it is something almost embarrassingly subtle. A tilt, a lean, a persistent, mathematically undeniable wobble in the architecture of the outermost solar system. A 6-degree discrepancy between where the ecliptic plane, the flat disk along which all our planets orbit the Sun, actually sits, and where it should sit according to every model we have built over 3 centuries of increasingly precise mathematics. 6 degrees. On paper, that sounds like nothing. 6 degrees is the angle your head tilts when you are mildly curious about something. 6 degrees is the temperature difference between your living room and your kitchen. 6 degrees is the kind of measurement error that would earn a first-year physics student a gentle correction, not a headline in the astrophysical journal. But when the entire ecliptic plane of our solar system is tilted 6 degrees away from the equatorial plane of the Sun, when every planet, every asteroid, every known body in our gravitational family is collectively leaning in the same direction, like a room full of people all staring at something in the corner that nobody is officially allowed to discuss, 6 degrees becomes the most alarming number in modern astronomy. For most of modern astronomical history, this discrepancy was filed in the category of interesting but probably explicable by something ordinary. Maybe the Sun formed slightly tilted relative to its own rotation axis. Maybe gravitational interactions between the giant planets accumulate over billions of years into a measurable inclination. Maybe we simply have not measured everything precisely enough yet. Then came the trans-Neptunian objects. Beginning in earnest around 2015 and 2016, astronomers Konstantin Batygin and Mike Brown at the California Institute of Technology published what has since become one of the most provocative papers in planetary science of the last half-century. They had been studying the orbital parameters of distant, icy bodies that exist beyond Neptune, objects with orbital periods lasting thousands of Earth years, swinging out to distances that dwarf everything in the familiar solar system. And what they found in the clustering of those orbits was not a coincidence, not a statistical artifact, not measurement error. What they found was a pattern. These frozen wanderers at the frontier of everything we call home were being herded. Their orbits were not randomly distributed, as they should be in the absence of a major gravitational influence. They were grouped, aligned, corralled into a coherent structure that screamed in the quiet mathematical language of celestial mechanics that something was organizing them. Something large, something massive, something that has never once appeared in any photograph, has never reflected a single photon toward our telescopes, has never been directly observed by any instrument built by any civilization in the entire history of Earth, something that the mathematics says must be there. The initial hypothesis, the one that briefly made Batygin and Brown the most talked about astronomers on the planet, was that this something was a planet, a 9th planet, a world perhaps 5 to 10 times the mass of the Earth, lurking somewhere between 200 and 800 astronomical units from the Sun, following an orbital path so elongated and so distant that it would take 10,000 to 20,000 Earth years to complete a single circuit around our star. Planet 9. The planet nobody has seen. The planet that might not exist. The planet that, if it does exist, would rewrite the textbook understanding of how our solar system formed and evolved over 4.5 billion years. But here is where the story shifts into something far stranger. What if it is not a planet at all? What if the thing at the edge of our solar system, the thing tilting the ecliptic plane by 6 degrees, the thing herding the trans-Neptunian objects into their suspicious orbital clusters, What if that thing is a black hole? Not the kind of black hole you have been imagining. Not the supermassive engine at the center of a galaxy. Not the stellar remnant of a dying star. Not something that devours planets and bends the visible universe around itself like a funhouse mirror at the edge of eternity. Something smaller, something older, something that should not exist according to any law of physics we understood before the 1960s, but that our best cosmological models now suggest was produced in the first fraction of a second after the Big Bang, in quantities so vast they may constitute a significant fraction of all the dark matter in the observable universe, a primordial black hole, roughly the size of a grapefruit, containing a mass approximately 5 to 10 times the mass of the entire Earth, and sitting, right now, somewhere beyond the orbit of Neptune, invisible, eternal, and almost certainly unchanged since the very first second of creation. Pause for a moment and let that settle. We are talking about the possibility that our solar system has, for the last 4.5 billion years, been in a gravitational relationship with an object that formed before the first star, before the first galaxy, before the first atom of ordinary matter had condensed from the primordial fire. An object that has been falling through space since before the laws of physics had finished stabilizing into their current form. An object that carries within it the compressed, frozen violence of the earliest moments of the universe. A moment so extreme that modern physics can only gesture at it from a respectful mathematical distance. We are talking about the possibility that we have been living, for the entire duration of human existence, for the entire evolutionary history of life on Earth, for the entire lifespan of our planet, in proximity to a monster from the beginning of time. And we have never known it was there. That is not a scientific footnote. That is a philosophical earthquake, and we have not yet felt all of its aftershocks. Let me try to give you the scale of what we are discussing, because the numbers involved span such extreme ranges that ordinary intuition becomes completely useless. And that uselessness is itself the point. The point is not to give you large numbers. It is to show you the precise location where human intuition quietly stops working and leaves you standing at the edge of a cliff you cannot see the bottom of. Begin with something you can hold in your hand, a grapefruit, about 12 centimeters in diameter, 400 grams. You know exactly what a grapefruit is. It is the most familiar possible object. Now imagine that grapefruit weighs 5 times as much as the Earth. Our planet has a mass of approximately 6 times 10 to the power of 24 kilograms. 6 septillion kilograms. Our entire planet, with its oceans, its mountain ranges, its iron core, every human being who has ever lived and all their buildings and machines and all the rock that has been cycling through geological time for billions of years. Now multiply that by 5 and compress that entire quantity into a sphere 12 centimeters across. What happens to matter under those conditions defies every physical intuition you have built through a lifetime of interacting with the world at human scales. The density is not merely large, it is categorically different from anything that exists in our everyday experience, categorically different from anything that exists anywhere in the current universe except inside the event horizons of black holes. At those densities, the concept of material stops making sense. There is no nucleus, no electron cloud, no quark configuration that can survive the compression. There is only space-time so severely curved that even the information about what was once inside cannot escape. The grapefruit is not a grapefruit. It is a point surrounded by an event horizon 12 centimeters in diameter. Within that boundary, nothing can move outward. Not matter, not energy, not light, not causality itself. The horizon is a mathematical threshold in space-time past which the geometry of space changes its fundamental orientation. Cross it, and every possible future path leads inward. The concept of outward has ceased to exist on the other side. The grapefruit is a doorway that only opens in one direction, and the direction it opens toward is the place from which nothing returns. Now consider where this object might be. The favored orbital region for Planet 9 places it somewhere between 200 and 800 astronomical units from the Sun. 1 astronomical unit is the distance from the Earth to the Sun. 93 million miles, a distance light crosses in 8 minutes and 20 seconds. 200 astronomical units means light takes roughly 27 hours to reach this object's hypothetical location. 800 astronomical units means more than 4.5 days of light travel time just to get to where this thing might be sitting. From that distance, the Sun would appear as simply the brightest star in the sky. Not the overwhelming, life-giving presence we experience on Earth, but a sharp, brilliant point of light indistinguishable in kind from the others around it. And yet this is still within our own solar system. The nearest star to our Sun sits 4.24 light-years away. 1 light-year is about 63,000 astronomical units. Even at 800 astronomical units, this object would be barely over 1% of the way to the nearest neighboring star. Not something remote, something in our backyard, gravitationally bound to our Sun, a member of the same family into which the Earth was born. Think about what humanity has managed to see. We have photographed the surface of Pluto in enough detail to distinguish mountain ranges from nitrogen ice plains. We have detected gravitational waves from black hole mergers billions of light-years away, ripples in space-time so small that they displace the mirrors of the LIGO detectors by 1/10,000th the diameter of a proton, and we detected them. We have mapped the cosmic microwave background radiation, the afterglow of the Big Bang itself, with a precision that resolves temperature variations of 1 part in 100,000 across the entire observable universe. We have ears that can hear whispers from 13 billion years ago. And this grapefruit, sitting in our own backyard, is completely invisible to every instrument we have ever built, because it does not shine, it does not glow. It does not radiate in any part of the electromagnetic spectrum in any detectable quantity. It is the least optically cooperative object in the known universe, and it may be sitting only a few hundred times the Earth-Sun distance from the one star whose planet we inhabit. We thought we knew what our solar system contained. And now mathematics is telling us the inventory might be missing something from before atoms existed, before stars existed, before time had been running long enough for the universe to become familiar with itself. Something from the very first second. To understand why this object would be so utterly invisible, we need to understand what a primordial black hole actually is, and how fundamentally it differs from every other black hole we have ever studied. Stellar mass black holes form when massive stars exhaust their nuclear fuel and collapse. We detect them through the X-ray glow of infalling material and through gravitational waves. Supermassive black holes anchor the centers of galaxies with masses from hundreds of thousands to tens of billions of solar masses. We have even directly imaged 2 of them with the Event Horizon Telescope. Primordial black holes fit in neither category. They were not formed from collapsing stars. They were not formed from any process that required stars to exist. They were formed from the direct collapse of density fluctuations in the primordial plasma that filled the universe in the first fraction of a second after the Big Bang, at a moment when the universe had not yet cooled enough for protons and neutrons to form stable nuclei, before any atom, any molecule, any structure we would recognize as matter had come into existence. In those earliest moments, space was filled with an extraordinarily hot, dense, nearly homogeneous soup of energy and elementary particles. But this plasma was not perfectly homogeneous. Quantum mechanical fluctuations imprinted tiny density variations in the early universe. Most of these eventually grew under gravity into the large-scale structure of the cosmos, the filaments and voids, the galaxy clusters and superclusters, the cosmic web. But some fluctuations, in the very earliest fractions of a second, were large enough to collapse directly into black holes before any stars existed, before any atoms existed, before the universe had even cooled enough for helium nuclei to form. These are primordial black holes, objects that formed not from the aftermath of the Big Bang, but from the Big Bang itself. Fossils so ancient that the universe around them was barely recognizable as the same universe we inhabit today. The theoretical framework predicting their existence was developed by Stephen Hawking and Bernard Carr in the early 1970s. The key insight: the mass of a primordial black hole is proportional to the total mass contained within the causally connected region at the moment of its formation. A black hole forming a few microseconds after the Big Bang would contain just a few Earth masses, precisely the range that the Planet 9 hypothesis requires. Since its formation, this object has done almost nothing. A black hole of 5 Earth masses has a Hawking temperature of approximately 60 billionths of a Kelvin, 60 billionths of a degree above absolute zero, roughly 800 million times colder than the cosmic microwave background radiation that permeates all of space. The black hole is so cold relative to its environment that it absorbs more radiation from the CMB background than it emits. Its Hawking radiation is completely negligible over any timescale relevant to the current age of the universe. The mass it carries today is, for all practical purposes, the same mass it had when the universe was a fraction of a second old. It is frozen, unchanging, older than any ongoing process we know of anywhere in the observable universe. And it is invisible for a layered set of reasons, each reinforcing the others. It emits no detectable light, not in visible wavelengths, not in infrared, not in radio, not in X-ray. Its Hawking radiation falls far below any instrument's detection threshold. It does not reflect light. This is the critical distinction from a conventional Planet 9. Every trans-Neptunian object and dwarf planet we have ever discovered was found by detecting reflected sunlight. But a black hole has no surface. Any light that encounters the event horizon is absorbed. The primordial black hole has an albedo of precisely 0. It reflects absolutely nothing. Its accretion signature is essentially undetectable. The space beyond Neptune is nearly a vacuum. Any accretion process at those distances is so slow and cold that it produces no detectable emission. The only way to find this object would be indirectly, through its gravitational influence on surrounding bodies, through the mathematical signature it leaves in the orbital parameters of the trans-Neptunian population, through the 6-degree tilt of the ecliptic plane, through the patient whisper it has been sending through the geometry of space around our sun for 4 billion years. This is detective work of the most profound kind, reconstructing the existence, location, and nature of an object purely from the distortions it creates in the fabric of space-time, without a single photon of evidence from the object itself, like reconstructing a presence entirely from the shape of its absence. In 2019, Jakob Scholtz at Durham University and James Unwin at the University of Illinois at Chicago published a paper in the astrophysical journal Letters that made explicit what had previously been only implicit. The orbital anomalies used to infer Planet 9 are fully consistent in every quantitative detail with a primordial black hole of 5 to 15 Earth masses sitting in the same orbital region. The paper demonstrated that the primordial black hole hypothesis was not theoretical excess, but a genuinely viable physical alternative, one deserving serious scientific treatment rather than dismissal as speculation. The universe may have placed a fossil of its own first second in our solar system. And if it did, we have not built the instrument capable of seeing it directly. Let us now walk the full spectrum of hypotheses in this conversation, because science is never a single answer. It is a structured argument between competing possibilities, and the architecture of that argument is itself deeply informative. At the most conservative end, we have the null hypothesis. There is no Planet 9, no primordial black hole, no undiscovered massive object in the outer solar system at all. The apparent orbital clustering of trans-Neptunian objects is entirely the result of observational bias, the tendency for astronomers to discover objects in regions of sky they have most thoroughly surveyed, creating a spurious appearance of clustering that reflects survey incompleteness rather than a true gravitational effect. The 6-degree ecliptic tilt has an explanation rooted in the early solar system's formation environment. Multiple careful statistical analyses have found the clustering signal weaker than initially reported. Many serious scientists occupy this position, and it cannot be dismissed. One step further, the standard Planet 9 hypothesis. A conventional planet in a highly eccentric, highly inclined orbit at 200 to 800 astronomical units from the Sun. Not yet discovered because relevant surveys have not been sensitive enough. The Vera C. Rubin Observatory, now surveying the entire accessible sky repeatedly to extraordinary depth over a 10-year mission, has a reasonable chance of finding a conventional Planet 9 if it exists. If the answer is a conventional planet, we will likely know within the coming decade. Here is the asymmetry that should stop us cold. If the object is a primordial black hole, the Rubin Observatory will tell us nothing. The Rubin Observatory works by detecting light. A primordial black hole of 5 Earth masses, at hundreds of astronomical units from the Sun, emits no detectable light and reflects none. A decade of the most powerful wide-field optical survey ever built could be pointed directly at this object every night of its operational life and return complete silence. The technology that will definitively test the planet hypothesis cannot test the black hole hypothesis at all. They require entirely different approaches to entirely different physical signals. To detect a primordial black hole, we need methods that do not rely on photons at all. One proposed approach involves gravitational microlensing. When a compact, massive object passes in front of a distant star, it briefly magnifies the star's apparent brightness. A primordial black hole in the outer solar system would produce a distinct parallax signature, a specific geometric shift in the lensing event over time as Earth orbits the Sun, that would immediately distinguish it from galactic-scale microlensing. A dedicated survey optimized for this parallax signature could potentially detect such an event if the approximate sky position of the black hole were known. Another approach involves extremely precise tracking of spacecraft trajectories. The positions of deep space probes can be measured to remarkable precision using radio Doppler techniques. An undiscovered massive object nearby would produce small but potentially measurable deviations in their predicted paths. The lesson of the Pioneer anomaly, an unexplained acceleration in 2 Pioneer spacecraft for decades, finally explained by asymmetric thermal recoil, is that spacecraft navigation is sensitive enough to detect subtle gravitational influences, but only after every other physical effect has been characterized with extraordinary care. The honest assessment is this: we have a real gravitational signal. The 6-degree tilt of the ecliptic is a measurement, not an artifact. And we have contested but suggestive evidence for orbital clustering of trans-Neptunian bodies. We have two major candidate explanations and technology adequate to definitively test only one of them. We are standing before a question we cannot yet fully answer, in possession of mathematics that points towards something we cannot yet see. This is a recognizable position in the history of science. Gravitational waves were predicted in 1916 and not detected until 2015. Nearly a century of theoretical patience. The shadow of a black hole was first imaged in 2019. The Higgs boson was theorized in 1964 and confirmed in 2012. The history of physics is a long catalog of predictions that inhabited theoretical limbo for years or generations before experimental technology finally caught up. Perhaps the primordial black hole at the edge of our solar system is the next entry in that catalog. Or perhaps the orbital anomalies have a mundane explanation and the universe at our doorstep is exactly what we thought it was. Both are scientifically possible. Both must be taken seriously, and the process of distinguishing between them, patient, rigorous, committed to the evidence, is precisely what science is built to do. Here is something we rarely allow ourselves to sit with in the ceaseless forward motion of scientific progress: the possibility that our not knowing might not be temporary. Science operates on an assumption so foundational that it rarely needs to be stated, that the universe is, in principle, knowable. That given sufficient time, intelligence, and technology, we can uncover the mechanism underlying any observable phenomenon. This assumption has been spectacularly productive. It underlies everything from the germ theory of disease to the detection of gravitational waves. The assumption of universal knowability has earned its status as the bedrock of the scientific worldview through 3 centuries of unbroken triumph. But every now and then, the universe offers a quiet reminder. The universe did not arrange itself to be conveniently visible to the sensory apparatus of a particular primate species on a particular rocky planet orbiting an unremarkable star in the outer arm of an average galaxy. The universe does not care whether we find its inventory accessible. It did not install warning lights on its most important contents. A primordial black hole in the outer solar system is, in a sense, the universe's most concentrated statement of indifference to our desire for a complete and legible picture. An object that cannot be photographed, cannot be directly measured by any current instrument, cannot be visited by any spacecraft we could build in any near-term future. An object that can only be inferred from the mathematical shadows it casts on the orbital architectures of distant frozen bodies drifting in the dark. An object that has been present, perhaps, for 4.5 billion years, through every era of life on Earth, through every moment of human existence, through every astronomer who has ever pointed an instrument at the sky with the sincere intention of understanding what is there. And it has remained through all of that completely and perfectly hidden. Let us speak plainly about what this hypothesis asks us to contemplate. It asks us to contemplate the possibility that our solar system, our home, our gravitational context, the family into which we were born by the accident of our star's formation, contains, as a permanent resident, an object from the first second of time, not the first million years. Not the first 1,000 years, the first second, an object that predates the formation of the sun by billions of years. An object that predates the Earth, the Moon, every planet and comet and asteroid. An object that predates every star currently visible in our night sky. An object that formed when the laws of physics were still establishing their current equilibrium, when nothing in the present universe had yet come into being from the primordial energy. Think of it this way. Imagine you learned in middle age that the house you grew up in, the house where you first looked at stars through a bedroom window, the house whose every room and corner you believed you knew, had a room in it that had always been there, sealed behind a wall that looked like every other wall, utterly dark, utterly silent. belonging to a previous tenant who moved in before the house was built, before the city was built, before there was a planet for people to stand on. And you will never open that door. Not because it is locked, but because the door is not visible from your side and you would not know where to knock. There is a particular quality of philosophical vertigo in sitting with this possibility. Not the familiar vertigo of discovering that the universe is large. We have managed that conversation many times, and the sheer scale of the cosmos has become, for most of us, a well-managed background awareness rather than an active terror. Not the vertigo of cosmic insignificance, because that truth has been so thoroughly absorbed into modern scientific culture that it has almost become a comfort. This is a different vertigo, the vertigo of incompleteness in our own immediate neighborhood. The vertigo of realizing that even the most local, apparently well-studied question, what is in our solar system, might have an answer we cannot obtain with any technology available to us today or in any near-term tomorrow we can plan for. Cosmology, at its deepest level, is the attempt by a species that has existed for roughly 300,000 years, on a planet that has existed for 4.5 billion years, in a universe expanding for nearly 14 billion years, to reconstruct the full history and structure of everything that has ever existed, using only the information that happens to reach us in the form of light and gravitational waves and charged particles. We are forensic scientists arriving at a scene after evidence has been accumulating for 14 billion years, with only a narrow observational window and remarkably clever instruments for reading whatever traces remain. And we must accept that vast quantities of information were never accessible to us, are not accessible now, and may never be accessible in any future we can plan for. The universe is not a library arranged for human readers. It is more like a library in a civilization that has only just invented language, vast, full, ancient, beyond comprehension, and mostly waiting in forms we have not yet developed the capacity to read. The primordial black hole hypothesis is a reminder that our cosmic detective work is constrained in ways that are not merely practical, but potentially fundamental. We cannot photograph something that neither emits nor reflects photons. We cannot measure the mass of something we cannot locate. And the most consequential possible discovery in the history of planetary science, the confirmation that a relic of the Big Bang itself is gravitationally bound to our own sun, might be achievable only through slow, indirect, statistical inference. The kind of inference where you never encounter the object itself, only the shape it makes in everything around it. What exists beyond Neptune might be a planet. If it is a planet, we will find it. We will photograph it, name it, study it, send probes to it, and eventually add it to the solar system atlas that has been accumulating detail since the era of the optical telescope. This is the comfortable version of the story, and it may be the true one. But what exists beyond Neptune might also be something that cannot be photographed, cannot be probed, cannot be understood through any quantity of telescope time or engineering ambition we can muster. Something that does not participate in the electromagnetic conversation that all of our instruments are designed to hear. Something that speaks only in gravity, in the patient, glacial gravitational nudge it exerts on distant frozen bodies drifting in the cold dark. Something whose only communication with the observable universe is through the curvature of space-time itself, and nothing else. If that is what is out there, then the most profound discovery in human astronomical history might be confirmed not by a photograph, not by a spectrum, not by a signal from our instruments, but by the slow accumulation of orbital data from 1,000 trans-Neptunian objects, each one carrying in the geometry of its path around the sun a tiny encrypted message from the very first second of time. And even if we decipher that message, even if the mathematics becomes conclusive, the statistical evidence overwhelming, the scientific consensus complete, we will still never see it. We will never look at it, never photograph it. We will know it exists the way we know dark energy exists, as a mathematical necessity, an invisible architect of everything we can observe, a presence inferred from its effects on everything else, never encountered directly, never imaged, never explained from the inside. We may spend the rest of the human species' existence looking toward the edge of the solar system, knowing something is there, knowing what it is, knowing how old it is, knowing approximately where in the sky it resides, and seeing nothing, just the empty sky, the same number of stars it has always had, the same patterns that human beings have been tracing with their fingers since before writing, before agriculture, before fire, since before we were fully human. And somewhere in that sky, in a direction we can approximately specify, a fossil from the first second of time is performing its patient, silent orbit around our sun, falling through space in the same curved path it has been following for 4 billion years, undisturbed by the emergence of life on Earth, undisturbed by the rise and fall of every species, every civilization, every scientific tradition that has ever looked skyward and tried to understand what the darkness contains. Older than our planet, older than every star currently visible in our sky tonight, older than the periodic table, older than atoms. We may be living in a solar system that has a monster from the beginning of time as one of its members. The universe is not required to make that easy for us to know. The universe is not required to make itself known to us at all. But here is the thing, and I want you to hear this carefully, because this is where the story becomes not terrifying but extraordinary in a way that goes beyond anything a simple discovery could offer. The fact that we suspect it is there at all. The fact that we can reason, from the slight tilt of a planetary plane and the orbital clustering of distant frozen bodies, backward through 4 billion years of gravitational history, to the inference that something from the first second of the universe may be orbiting our sun. That inference is one of the most remarkable things a mind has ever accomplished. We did not detect it with a photograph. We deduced it from mathematical ghosts. We found the shadow before we found the object casting it, and we were not even certain there was a shadow. This is what science does in its finest moments. It reasons from the visible to the invisible. It follows the mathematics where the light does not go. It stands at the boundary of knowability and does not retreat. It leans forward, squinting, building better instruments, refining its models, pushing the edge of inference as far as it will carry us. We may never directly see the primordial black hole beyond Neptune, but we are the species that looked at a 6-degree tilt in the ecliptic plane and said, something is there. Something we have never seen. Something that may have formed before the universe had atoms. Something from the very beginning of time, and we are going to find it or explain why it cannot be found, which is its own extraordinary form of knowing. The grapefruit sits in the dark, silent, ancient, smaller than your hand, heavier than 5 Earths, unchanged since the moment the universe permitted physics to begin. It was here first. And we are only now learning to ask the right questions about what has been sitting in our neighborhood since before there was a neighborhood, since before there were stars to anchor a neighborhood to, since before space itself had cooled enough to be called a place at all. We look into the outer solar system with our mathematics and our orbital surveys and our carefully sharpened inference, and we say, we think you are there. The grapefruit does not answer. It never has. But we are asking the question. And the courage to ask the question, given everything, has always been enough.